Hello friends, welcome to all of you in this session. Today we are going to learn about limit test. I am Professor MG Sinde, Kekawa College of Pharmacy, Nasik. Welcomes to all of you. The learning objectives of today's session: to know the definition of limit test, to know the different principles of different limit test, procedures and conclusions. So first of all, what is limit test? While we have to perform different limit tests, we must know what is the limit exactly. A limit is the value or amount that is likely to be present in the substance. Test means to examine or to be investigated, while the impurity is any type of foreign matter that is present in the compound or solution. So let's see the first limit test definition. We can say that is limit test should be defined as a quantitative or semi-quantitative test which is designed to identify and control small quantities of impurities which are likely to be present in the given substance. What is the importance of the limit test? Limit tests are important to find out the harmful amount of impurities in the given solution, while we can find out the avoidable or unavoidable amount of impurity in the given solution or given sample. There are three types of the limit test we can say. We can perform the limit test either with the help of comparison method, second by quantitative determination method where we can determine the percentage value, while there is third type in which there is no visible reaction to be observed. Now, before proceeding to the different limit test, we must know the general principle behind the limit test. A limit test having a general principle that we have to compare or sample with the standard solution. If the sample is a lighter in case of either the opalescence or color than the standard solution, then we can say that is the sample containing the impurities within the limit. That means within the pharmacopy limit. That time we can say that is the given sample is to be accepted. While if vice versa, if the sample is darker or heavier than the standard solution, then we can say that is that contain more impurities as compared to the standard limit. So that time we can say that is the given sample fails as per the pharmacopoeial limit, and that time we can reject the given sample. Now, what are the general precautions should be taken while performing the different limit test? While performing the limit test, we have to take the following general precautions. The liquid used must be clean and filtered if necessary. The Nestle cylinder must be made of the colorless glass and of the same inner diameter. Next, that is the detecting opalescence or color development must be performed in the daylight only. When comparing the turbidity, it should be done against the black background. While if we are comparing the color, it should be done against white background. So these precautions we have to take while performing the limit test. So first of all, we must know about the Nestler cylinder. Nestler cylinder is a clear glass cylinder with the normal capacity of 50 ml, which is having overall height is a 50 centimeter, and external height to the 50 ml mark should be not more than 11 to 12.4 centimeter. The thickness of wall of the Nestler cylinder is around 1 to 1.5 mm only, while the thickness of the base should be not more than 1 to 3 mm. The external height to the 50 mm marks of the cylinder used for the test must not differ by more than 1 mm. So this should be a specification for the Nestler cylinder while performing the limit test. So this is the pictorial diagrams of the Nestler cylinders. Now let's see with the first limit test for chloride. So first of all, performing the limit test, we must know the principle behind the chloride limit test. This test is mainly used to control the chloride impurity in the given inorganic substance and depends on the simple reaction between the silver nitrate and soluble chloride to give a insoluble silver chloride in presence of the acidic environment, that is the dilute nitric acid. The insoluble silver chloride makes the solution opalescent, and the extent of opalescence depends upon the amount of chloride impurity present in the given substance. We have to compare this opalescence with that of standard opalescence produced in the standard solution, in which standard amount of chloride is present. Now, all this should be performed in presence of dilute nitric acid. If the opalescence produced in the test is less intense than that of standard opalescence, that time we can say the sample passes the limit test for chloride. While if the opalescence is more darker than the standard, then we can say that is the sample contain more impurity than the standard, and that time we can say that the given sample fails the limit test for chloride. Here the dilute nitric acid plays the important role for the precipitation of other acid radicals with the silver nitrate solutions. So this is the common role. So this is about how the chloride limit test. The chemical reaction is that chloride ion that reacts with the silver nitrate, and that will give formation of silver chloride in presence of the acidic anion. What we have to do? The following procedure we have to follow. So a simple procedure that we have to take two cylinders, Nessler cylinders. Both these Nessler cylinders should be of 50 ml capacity. Mark them as a test and standard. In the standard, we have to place 10 ml 0.05845% weight by volume solution of sodium chloride in Nessler cylinder. While in the test, we have to dissolve a specific amount of quantity of the substance as per specifications, and then transfer to the Nessler cylinder. In the both Nessler cylinder, we have to add 10 ml of dilute nitric acid. Then we have to add 1 ml of silver nitrate solutions, and we have to immediately stir after addition of the silver nitrate both the solution and allow them to stand for 5 minutes. Before that, we have to adjust volume to the 50 ml with the help of distilled water. Allow them to stand for 5 minutes and then observe. Whatever the opalescence develop, we have to compare that opalescence of test solution with that of standard. If the test solution having opalescence less than the standard, that time we can say that the given test sample contains less chloride impurity and it will pass as the limit test for chloride. Vice versa, if there is more opalescence in the test solution observed than that of standard, that means it is having more impurity than the given specified standard amount. So this is how we can perform the chloride limit test, which is to be dependent on the production of the opalescence. So we can conclude that the chloride limit given unknown sample passes chloride limit test if the opalescence produced by the test sample is less as compared to the standard. That means it is having less impurity. Now let us see the next limit test for iron. The principle behind the limit test for iron is based on the formation of pale pink or reddish deep color by the reaction of iron with the thioglycolic acid in presence of citric acid in the alkaline environment, which is to be developed by the help of ammonia solution. The color due to the formation of coordination compound ferrous thioglycolate. The color produced is compared with that of standard solution containing a definite quantity of iron. Now here we have to observe this color weaving transversely through Nessler cylinder against the white background. Here we have to note that the citric acid is to be added to prevent the precipitation of iron by the ammonia. Citric acid makes a soluble complex with iron and ammonia will do not able to precipitate iron. So for this we have to provide this alkaline medium. Now look at the chemical reaction. Here a soluble iron that reacts with the thioglycolic acid and that will give the formation of a iron thioglycolate complex, which will show the reddish violet color. So this is the simple procedure we have to follow. If we look at, so this type of pink or violet color to be developed in the iron limit test. Now a procedure for this iron limit test similar chloride limit test, we have to take a 250 ml Nestler cylinder. We have to label them as a test and standard. Now, first of all, we have to take a standard Nestler cylinder. In that, we have to add 2 ml of standard iron solution with 20 ml of distilled water. At that same time, we have to take a test Nestler cylinder. We have to dissolve a given unknown substance in the specified quantity as per the specification in the distilled water and transfer them to the Nestler cylinder. Now, in the both cylinder, we have to add 2 ml of 20% weight by volume solution of the iron free citric acid and 0.1 ml of thioglycolic acid and mix them thoroughly. Now, we have to make both the solutions alkaline with iron-free ammonia solution. We have to take care that the ammonia should be free from iron. Now, dilute both the solution to the 50 ml mark with the help of distilled water and allow them to stand and observe the intensity of purple color which is to be developed in the test sample, that is to be compared with the standard. If the intensity of purple color or violet color to be developed in the test sample is less as compared to standard, we can say that the test sample passes the limit test for iron. Vice versa. While we have to note that whenever we are going to observe the intensity of this purple color with or compare this intensity of purple color with the standard, we have to observe it against the white background. So here we can conclude that the given unknown substance or the given test sample passes the limit test for iron. That means it is having less iron impurity as compared to the standard, vice versa. Thank you. We will see in the next part the limit test for arsenic, heavy metal, lead. Thank you.